So let's highlight the arc length formula. Oh, I need to erase the board. The arc length formula, thank you, Nate, is that S equals theta times R, where S is the arc length, and then theta is the angle measure, but we have to make sure that it's in radians. So if it's not in radians, we use our conversions from above. And R is the radius of the circle. And what you're going to really notice is that the arc length formula is really taking a fraction of the circumference. We're basically figuring out what measure or what fraction of that whole circle am I dealing with. So that's why theta has to be in radians, because theta is going to tell us basically what fraction of the whole circle we're dealing with. So let's first, and we're going to leave our answers in terms of pi. Let's first just using the formula. So it says to find the length of an arc of theta of 5 pi 6 and radius of 4. Let me just explain what we're doing, okay? Here's my circle. I should have drawn the XY axis. 5 pi 6 is from, if I started from here and I went all the way over to right, it's pi 6 shy of 1 pi. Okay. So that highlighted, I'm finding the length of that highlighted piece. That's what I'm doing. That's what S is. So we are going to take theta times R. Theta is already in radians, isn't it? So we're going to leave it. 5 pi 6 times 4. I'm going to reduce these both by 2. So this is a 3 and a 2. So 5 pi over 2, or 5 pi times 2 is 10 pi thirds centimeters. In the next one, we'll see if we can do it exactly or not. Not sure with the decimals there. I want to find the arc length of 125 degrees and the radius is 1.5 milliliters. Millimeters, not milliliters. So in other words, I know that this is not a radius of millimeters, but let's say I went out and I said this was 1.5 milliliters from here to here, and I made a circle all the way around. This is 125. I'm trying to find the arc length from here and 25. Where is that? 35 degrees past 90, so maybe to right there. I'm trying to find the length of this. That's what the arc length needs. Now, if theta is not in radians, we're going to just go ahead and convert it to the formula. So I have 125 degrees. I would need to have it in radians, so I'm going to multiply by pi over 180 and then times the radius. I am going to use my calculator a little bit on this one. Can you guys reduce these to 5 for me? If you can't do that in your head, you can use it. Well, I can. Let's think. 120. That's 25, right? Over 36. But I don't think you're going to... I don't think we can go any further on that, can we? So we would have to leave that as, let's just calculate as a decimal. What is 25 times 1.5 over 36? I want the answer in terms of pi, so we're going to leave that out. So let's see, that would be 7.5 over 36, right? Which is about what? Is it a repeating thing? No. One.
Like 1.041 and then it starts reading 6.
There. That's the most exact pi. Okay. So that's a little bit of arc length. I might sometimes give you the arc length and you have to solve things. You just solve that like you would an equation. The key thing there is make sure theta is in radians if you're going to use that. Then the last problem, the last on today, is angular motion. Okay, an angular motion is based on an angle. So like we're talking about revolutions per minute thing. So maybe with a bicycle wheel or a car wheel. I'm trying to think what other. Oh, I think there's a problem in the book today about a saw, like a circular saw, its speed. Something's linear speed is flat. Okay, so if I wanted to know how something was going this way and how it related to that way, that conversion has to do with arc length in a way. Actually, this is what car does when it's finding your miles per hour or kilometers per hour. It doesn't just know that. It bases it on the speed that your wheels are. So, what would happen if you would put the wrong size wheels on your car then?
Wheels.
Your speedometer would be wrong because your speedometer is based on its angular motion, which is based on the radius of. Because if I have a radius that's bigger, isn't it going to cover more distance by going around once? So if you put wheels that are too big on there, your speedometer is probably giving you a speed that's less than what you're really going. That's why if you would ever buy a car and replace tires, there are specifications for what the tire dimensions should be. Let's take a look at this, see how it works, and then maybe we'll do another practice one together out of the book. A turntable rotates 50 revolutions per minute. I want to know its angular speed in radians per second. Okay, so at least I'm leaving this in radians, and radians just means I need to have a pi in my answer, okay? Do you remember yesterday what I said one revolution was?
It's equal to a circle.
Good. One revolution equals one circle of the circle. So one revolution is pi times d. Oh. Did I not give you d? Huh. Let's give you d. Oh, we can still figure this out maybe. We'll do it in terms of d. Okay. All right. So I want to find its angular speed in radians per second. Okay. So if it does 50 revolutions per minute, there's going to be 50 of this. Does that make sense? So I have 50 pi times whatever the diameter is in 1 minute. In 1 minute. So this part right here converted this revolutions to radians because I have pi in my answer. Okay? Yes, sir.
In the second operation, you mean what you said that 50 times pi times d?
That's how many radians it goes.
Parentheses in 3 times d.
No, because it's all multiplication. Yep. If it's all multiplication, you don't use parentheses. Okay? How would I get that to convert to seconds? So I like to, I need the minutes to cancel, so is it times 60? It's 1 divided by 60 because 1 minute is 60 seconds. So I use fractions that are stacked like that, and I make sure I have the units canceling. So the minutes are going to cancel here. Okay, so that would be 50. Do you see that word cancels? 50 times I times whatever the diameter is over 60. Can you reduce that fraction at all? So 5 pi over 6 times the diameter radians per second.